Hello everyone, myself Rupam Das, Assistant Professor of Asansol Engineering College in Electronics and Communication Engineering Department. Name of the subject is Signals and System. Learning outcomes are at the end of the session, student will be able to understand state space analysis. Contents are state space analysis, state, state variable, state equation, state model, and also the transfer function. Reference books are first book Signals and System by Anand Kumar. Second book is Signals and System by Torun Kumar Rawat. Third book is Signals and System by Ramesh Babu. Fourth book is Signals and System by Nagor Kani. So these are the books by which you are very much able to understand this state space analysis. Now next is the definition of state space analysis. Before going to that, the state space analysis is a modern approach and it is very also easy to analyze using digital computers. The old method of analysis imply the transfer function of the system. So the drawbacks of the transfer function of the model and analysis are transfer function is defined under zero initial conditions. Transfer function is applicable to linear time invariant system. Transfer function analysis is restricted to signal single input and single output system, and the transfer function does not provide information regarding the internal state of the system. So the state model of a continuous time system, you are having some definition. So first definition is state, this particular point state, and second definition we are going to see the state variable. So the state means the state of a continuous time system is defined to the condition of the system at any time instant, so which is described using minimum set of variable called state variable. The knowledge of the state variable at t is equal to 0 together with the knowledge of input for t is equal to t greater than 0 completely describe the behavior of the system at t equal to 0. So next is state variable. The state variable are set of variable that completely describe the state or condition of the system at any instant time. So these are the two definition for state variable. Now next we are going to see state equation. Now suppose that consider one continuous time system with m input and n state variable and p output. So one system is there which has m number of input state variables are there, n number of state variables are there, and p number of outputs are there. So in this particular block diagram, x1, x2, x3 up to x of m, these are the inputs. N number of state variables, that is denoted by q1, q2, q3 up to q of n, that is state variable, and as well as number of outputs are also there, y1, y2, y3, yp. These are the outputs are also there for output of the system. Next we are going to see the state equation. So that can be described one formula. So I am highlighting the point, the state equation can be performed or formed by taking the derivative of the state variable as a function of state variable and the inputs. So you have to know the derivative. So here in this case derivative is denoted by q1 star to the power dot. So you can see here q1 star q1 t of dot, that is denoted by derivative, and for this case it is a function of state variable as well as the input. So x1, x2, x3 up to dot dot x of mt, these are the variables and these are the inputs. Now to do this one by one, I'm going to define each and every state variable for q1, for q2, for q3, as well as up to dot dot q of n. So for each and every cases you have to define the state variables. These q are the state variable and this q1, x1, x2, x3, these are the state equations. So you have to describe the total system with the help of this equation. So that means basically at the input side we are going to obtain some variables, or we are going to evaluate some equations. Now depending on that we can write mathematically the above equation can be formed by the derivative of n number of variables and can be expressed as q1 start t. That is, we are now going to denote one term. Q is associated with a for the first case, so that is denoted by a11, then it is a12, then it is a13, up to dot dot a of 1n for q, for this particular q case, q1, q2, q3 and q1 case. But once we are going to go for x1, x2, x3 up to dot dot up to x of m, we are going to use this particular term, that is b11, b12, then b13, like in this manner you are going to hit. So if I'm going to expand the total series for q2, so that should be denoted by a21, and for x1 it is denoted by b21, for 3 it is a31, for qx it is denoted by b31. So like in that manner the whole system is going to be expanded, like in this particular formation of equation the whole system is denoted like this. Now if I'm going to jot it down the whole system in a particular jotted down matrix type of equation, that see this total thing, this total expression can also be written as like this. So we can use this, just the above equation can be first derivative of n number of variables called state equation, and can be expressed as the matrix from shown in the figure. So here in this case we are going to describe the whole thing in a matrix: q1 dot t, q2 derivative of t, q3 derivative of t. At a time it is going to be make a summation, and it is represented by q1 t, like in this manner. Now similarly for a1, a2, a3 dot dot up to 21, 22 dot dot a31 dot dot, so it can be denoted by a. Similarly q1t, q2t, q3t is denoted by this term qt. Similarly b is written by b, and this last term is denoted by xt, where a is the system matrix, b is the input matrix, qt is the state variable, and these are the input vector. So one by one these are the total term which I have described it over here. And finally the matrix form of the state equation can be written by like this: key q star dot t, that is a of qt plus b of xt. So this is the equation for the input cases which I have shown over here. So in this way the state equation can be formed for the input side, and depending on that you definitely have some mathematical question. Output equation next. The output equation can be formed by taking the output of the function of state variable and inputs. Therefore p outputs can be expressed as y1t, that is function of q1, q2, q3, q dot dot qn. These are the state variables, and x1, x2, x3 dot 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 up to x of m, these are the state inputs are there. So we have to represent y1t, y2t, y3t, like in this manner the whole system is been denoted. Just like inputs, the output is also represented like in this particular manner. That means y2t is also there is a function of q1t, q2t, q3t, and these inputs are also been represented x1t, x2t, x3t, like in this manner. So in this way the whole system is been described. So after that we are going to combine all the equation, we have to expand this equation. Now in this case the mathematically the above functional form of the output can be expressed in this manner. So y1t is written like in this manner: c11 q1t, c12 q2t, c13 q3t dot 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 up to c1n qnt. So that means q part is associated with c, and the x part is been associated with d, that is d11, d12, d13 up to d1m. So like in this manner for each and every case, that means for y1, for y2, for y3, and also for yp, you are going to expand the total series in terms of c and in terms of d. So just like for example y2t is denoted as c21 q1t, c22 q2t, then c23 q3t plus dot dot c2 of n q n of t plus d21 x1t, d22 x2t, d23 x3t plus d2 of m x mt. So in this way the y2 is being denoted. In the same manner, y3 can also be represented as like this, ki y3t, that is c31 q1t, c32 q2t, c33 q3t, and c3n of qnt. So in the same way, x part can also be written as d31, d32, d33, and d3 of m. Like in this manner, the total system is being denoted, and mathematically we expand the series starting from y1 to yp of n, the total system we have to describe. Now we are going to jot it down the whole system in a matrix form. So in the matrix form, you can see here, uh, you can observe from this particular section ki y1t and y2t and y3t, it is being formed in a matrix. Similarly, c11, c12, c13, it is also formed in a matrix. Similarly, q1, q2, q3, it is also formed in a matrix. And also d1, d2, d11, d12, d13, d21, d22, d23, d31, d32, d33, it is also formed in a matrix. And also x1, x2t, x3t, it is also formed in a matrix. So in the same way, we are going to combine the all parts in a particular form. Suppose yt, c is been written c, and q is been written qt, d is been written d, and also x is been written xt. So here c is the output matrix, then qt is the state variable matrix, state vector, d is the transmission matrix, and xt is the input vector. So if I'm going to combine the whole system, therefore the matrix form of the output equation can be shown in this particular equation, ki yt is equal to c of qt, that means this particular equation, c of qt plus d of xt. Now if I'm going to combine, the state model can be formed. This is the state model, that is state model of the continuous time system is given by the state equation and the output equation. So the state equation can be written q dot t, that is the derivative, that is a of qt plus b of xt. This is the equation. And second equation, the output equation, that is in terms of output, so that is yt is equal to c of qt plus d of xt. So in this way, these two equations are being basically formed to obtain the state model of a continuous time system. Now next is state model of a continuous time system, direct form 2 is structure. So consider one equation of this state equation. So here in this case, d3 divided by dt to the power 3 yt, a1 d square dt square yt, a2 d of dt yt, a3 yt, that is equal to b0 d square dt q xt, b1 d square dt square xt, b2 d by dt xt, and b3 xt is been written. Now direct form to structure of the system is described by the above equation, as shown in the figure. Here in this case, direct form to structure of a continuous time system can be written xt. This is the representation of this particular structure. Now from this we are going to extract the equation. So in the next slide, I'm going to represent this total structure. So here, this is the first derivative, this is the first derivative, this is the second derivative, and this is the third derivative. So the first derivative, that is denoted by q1 dot of t, that is the derivative of q2. Then q2 dot t, that is the derivative of q3, and q3 dot t, that is the combination of this particular term, that means a3 q1t, a2 q2t, and a1 q13. So like in this manner, the whole system is been jotted down at a time, and also xt part is also there to obtain this the total thing. This is the state equation. Now if I'm going to represent the state equation in terms of a matrix, so this can be represented form in the form of like this, q1 dot t, that is 0 of q1. So in the first case, q1 term is not there, so that is 0. Then q2 is there, so that's why it is 1. Then after that, there is no term of next part, so that is of 0, and xt pass is also not there, so that is 0. So in the same way, q2 dot t is been written 0 of q1t, 0 of q2t, but q3 is there, so that is 1 into q3t. Then on 0 of xt, so 0 of xt, that means no xt part is there in this particular equation, so that is 0 of xt. Similarly, q3 dot of t, that is minus a3 q1t minus a2 q2t minus a1 q1t and 1 into xtt. So this is basically form the state equation. From that state equation, we are going to write down the matrix formation. So here you can see here the first part, that is the q that start q dot of q dot 1 of t, q dot 2 of t, q dot 3 of t, it has been written. Now as per the previous case, we have used one a type of a time a representation of the matrix equation, so it can be written 0 1 0, then 0 0 1, then a3 a1 minus a2 and a2 a1. Similarly, it is associated with q1, so this term has been written. The last part, which is associated of xt, that is denoted of b in terms of a xt. So in this way we can arrange the state equation in the form of a matrix form. So in this way you are going to represent this thing. Now next is output side. So in case of output side, we can see this is the input side, this is the output side, these are the output side. So we can write down the yt structure. So yt can be written b0 of q3 dot of t plus b3 q1 of t, b2 q2 of t, and b1 q3 of t. So from this particular structure you can represent the total thing here. But previously we have simply evaluated this particular term, that is q3 dot of t. So simply here after b0 I have written the total expression. This I am highlighting the part, this is the expression for q3 which you have evaluated, and rest of the part you simply write down. Then in the second line you have to simplify the expression. After simplification and on arranging the output equation in matrix form, we can write down yt, that is in terms of a c, this is in terms of a c, and also this is in terms of a d. You have to write down the total expression like in this manner. After that we are going to obtain the state model. The state model of a continuous time system is given by the state equation and the output equation. The state equation can also be written as q dot of t, that is a of qt plus b of xt. This is the expression of the state. Then on you have to represent this q dot of t, this particular term. Then a and qt basically the q1t, q2t and q3t. A is the matrix which you have evaluated here. B is denoted by this particular section, that is 0 0 1 which you have evaluated, and xt, that is the term of the input. And similarly the output equation which you have obtained previously, that is yt is this particular term, you can see here. C is this particular term which is written over here. Qt basically this particular term which is written over here. D is this particular term which is written over here, and finally this is the xt which is written in this particular case. So in this manner you can obtain the state model of a particular system. After that we are going to evaluate the transfer function. To obtain the transfer function of a continuous time state model, consider the state equation. So first equation, that is q dot of t, that is a of qt plus b of xt. By taking the Laplace transform of the above equation, we can obtain the initial condition. So it can be written t has been replaced by s, so s of qs plus a of qs plus b of xs. So after that we are going to simplify it by taking common of qs, so it can be written s of I minus of a qs, that is equal to b of xs, where I is the unit matrix. On pre-multiplying the above equation by s of I minus a to the power minus 1, we get q of s, that is equal to s of I minus a whole to the power minus 1 b of xs. So it can be written like this in this manner by taking. So that means to obtain the transfer function of a continuous time LTI system, you have to use the Laplace transform. So transfer function, that means basically output by input. So we have to obtain next the output equation. This is the output equation we have to obtain, that is yt, that is c of qt and d of xt. Again I have to take the Laplace transform, so it is coming y of s q of c of qs plus d of xs. Now qs you have evaluated previously, so this particular term can be written over here. So that is, we have simply put it down the value over here, so that is c into si minus a to the power minus 1 b of xs, and this particular part as it is there. As I'm telling, if I'm going to evaluate the transfer function, it should be output by input. So output is denoted by ys and input is denoted by xs. For doing this, from this particular total expression you have to take a common of x's and write down the total expression. This expression should be looking like this, and after simplification the single input single output system transfer function can be written ys divided by xs, that is equal to c into si minus a and to the power minus 1 of b plus of d. So this is the total expression for the transfer function. In this way you can evaluate the transfer function, and definitely you are having, depending on that, some mathematical question on this. So up to this I am concluding today's session. On next session we are going to have some mathematical question depending on these formulas. Thank you.